All right. Let me see. Let's go here. Let me check one more time. Okay, that was good. We're going to share the screen. And we'll start off here while we do morning announcements for your everyday life, vital information for your everyday life. Okay. Welcome, YouTube. Welcome, scholars. We are at the end of week 6, right? The only real announcement is that, week 8, we can anticipate exam 2 to become available, right? So that's Sunday at 11/11 before week 8. I think exam 2 will become available on Pearson. Exam 2 will cover the material from weeks 5, 6, and 7, right? So right now we're in 6. And let's just we're in week 6. And, as usual, this is remote asynchronous. So, if you're in the Zoom call right now, that means you've gotten your attendance credit. You're not obligated to stay. I might get a little upset if you leave, but not going to make a big deal about it, to be honest. Again, everything is recorded. There is a recording. You were here. You're showing that, when you get into the Zoom, it's like saying, hey, I'm okay. I don't really have any questions. This is, I'm fine. So then, I try to let it go. And so what I wanted to do today was to take some time and go through as many of the homework questions as we can from corresponding to this section. And again, if you want me to jump to a specific question, you just have to request it. My philosophy is the only dumb question is the one that I asked. Okay. And I think also what I've been doing today with the students, we've been doing a poll, right? So with the multiple choice questions, let me go ahead and start the poll. And in order for me to move forward, let's try to get at least 40% participation, right? Okay, so let's see it in action. Right? So then this says describe the transformations that produce the graphs of G and H from the graph of F. So F is going to be the square root of X. And so for part A, we're saying the square root of X plus 3, where that plus 3 is on the outside. Okay. This should be fine. Let me do this instead. Okay, that looks a little bit better. But now you can't see that. Okay, so there is a poll. Yeah, this doesn't work for me. Let's go like this. And then what we can do here is let's zoom out. That's better. Okay. Oh no. Oh no. Don't restart it. Sorry. All right, hang on, because I'm gonna reboot this because it's just not behaving properly. Hang on. All right, let's go with this one. Okay, so there is a poll that's live on our Zoom call. And so again, we're starting with square root of X and we're adding plus 3 on the outside, right? So part A asks us to describe the transformation that produces the graph of G from F. And then which one is correct? Is it A, B, C, or D, right? So there is a poll. Oh, let's launch the poll. That's probably a good idea. Okay. So there's a poll that's available on Zoom, and you can basically hop over to Zoom and choose which one you think is correct. Is it A, B, C, or D? And I can't move forward until we get at least 30% participation, right? Let me see. So maybe 4 people, right? All right, so we got 1 vote for A. Let's see. So we're adding 3 on the outside of the square root, right? So when we add things outside of our basic function, that's going to affect our Y values, right? We still need, I think we need at least 2, maybe we need 3 more people. So when we do manipulations outside our basic function, that affects our Y value, right? So if we're adding 3 on the outside, it's basically the same as adding 3 to every Y value, right? So is the result A, B, C, or D? And if you want me to get through more questions, we just got to get the participation going faster, right? Otherwise, we're just going to waste a lot of time, all right? So then part A, okay, we got 2, and we're at 18%. I'm trying to get at least 30% participation, if not more. We need 1 more. We got 3 is 27. 1 more, right? And it's anonymous, we don't know who it is, right? So it's not going to hurt you, right? Let's see. So we still need 1 more. Okay. So then part A says we're going to shift 3 units to the right Okay, part B says shift 3 units to the left. Remember, we're only affecting the y, right? Because we're adding that 3 on the outside, so it should affect the y value. It's like adding 3 to every y value. The x values stay the same. Part C says shift 3 units up. Part D says shift 3 units down. We still need one more, at least one more, to give it a go, right? And I think you can change your answers as well if you need to. Okay. I'm just going to keep yammering until we get at least 30%. Like, you know, you don't want to waste your time. Otherwise, you know, what are we doing here? All right. So let's see. If we're adding 3 on the outside, so that means that for every x comma y that we have, again, the x values are going to stay the same. So we're adding 3 to every y value, right? So we're still at 3. All right, I think I might have to go and readjust this attendance because it looks like nobody's here but 3 people. All right, are you guys here? Oh, all right. I'm gonna go on to the next one there because we only got 3 there. Oh, okay. I was like, I know it's at least one more person there. There is a 30. Okay, C, right? Now the moment of truth, right? Because it says we're adding a 3 on the outside, so that's going to affect the y. So all the y values get 3 added to them, so that should shift the graph up. My vote is going to be C, right? I'm going to go against the audience. Well, I feel like we can do like a Who Wants to Who Wants to Be a Millionaire. I know that show was probably outdated, but I would have told the audience in that one. That one was wrong. Let's try another one, but that's okay. Let's relaunch it. Let's relaunch it. I got to find a way, like if we do that, where audience has stake in it as well. Let's launch it, and we're just going to run that back, right? So then for part B, right? So part B, the manipulation is still outside, but now instead of adding 3, we're subtracting 2, right? So is it A, B, C, or D? Okay, so let's look at this. So A says shift 2 units down, B says shift 2 units to the left, C is 2 units up, and D is 2 units to the right? Okay, I'm still looking for my 30%. I think we said before, outside manipulations typically cause a vertical change, and it follows our intuition, right? So manipulations that are outside of our basic function typically cause a vertical change. I think we just need one more, and typically follows our intuition. Okay, my vote, I think I'm going to go with the audience in this one. The audience is choosing A. Let's just go with A, and let's see what it's looking like. Cool beans, right? Because again, we subtracted 2 on the outside, so it should take the whole graph and go down by 2. Okay, let's go into the next one. Let's try another one. Okay, so now the root function, we're starting with the absolute value. Let's just restart the poll. Just relaunch it. Okay. So now we're starting with the absolute value of 5x, right? And so for part A, we're multiplying the outside by a negative, right? So then, so I'm still looking for, I need at least 4 people to participate. Now there is a vote for B. We're multiplying the outside by a negative. So remember, outside manipulations typically cause a vertical change and they follow our intuition, right? So when we multiply the outside by a negative, it's like our y values are going from positive y to negative y. So which one of these choices might encapsulate the idea of y going from positive y to negative y, right? Does that mean that we're doing a horizontal stretch by a factor of 5? Does that mean that we're reflecting over the x-axis? Does that mean that we have a vertical stretch by a factor of 5? Or does that mean that we're reflecting in the y-axis, right? So for part A, I need one more. Now, I think I might export these just so I can see who's engaging. I think I will. I think because there is a way for me to look at this. I need one more. Because, you know, you're not having to say anything. Okay. Oh, ooh, see, now I'm making it a little spicy. Now that if I'm checking, you know, that's what one of my mentors would say. He was like, you have to inspect what you expect, right? And I know this has been very hands-off. It's okay. I mean, you know, for now, you know, until we do something different. But yeah, B looks good. Okay, so then for part B, now instead of multiplying, I think you can actually just change. But let me relaunch the poll. I feel like relaunching it is better, even though we can still use this one. Let me just relaunch it. I feel like that's a little bit better. Okay, so for part B, So now, instead of multiplying the outside, we're multiplying the inside. So in part A, and I'm just yammering until I see like 30%. In part A, again, we multiplied the outside by a negative, so that caused a vertical change. And it was correct that it flipped vertically over the x-axis. So your intuition should kick in, right? And that is a huge hint. Now we're multiplying the inside by a negative, right? So if outside caused a vertical change, then that stands to reason that multiplying the inside should cause a horizontal change. And since part A caused it to flip vertically over the x-axis, then it's a good chance that this one should cause it to flip horizontally over the y. So let's see if that pops up for any of them. Part A says that it's a vertical stretch by a factor of 5. We're at 18%. Part B says a horizontal stretch by a factor of 5, okay? C says reflecting in the y-axis, and D says reflecting in the x-axis, okay? So remember, so for part A, we multiplied the outside and it caused a vertical change. For part B, now we're multiplying inside our basic function, so it should cause a horizontal change. So then if it's causing a horizontal change, let's get one more vote. Let's get one more, we just need one more person. Multiplying the inside by a negative should cause a horizontal, so it should be kind of almost like the reverse of the previous, right? Okay. I just for the sake of time, I'm going to go with my guts. I'm going to say flipping over the y-axis, right? So I think the audience chose D, but D was not correct, right? Hopefully you understand why that's not correct. Hopefully you understand, like if it's not clear, you just have to ask. Let's try another one. Okay. Describe, okay, so I think this one is not multiple choice. To obtain the graph of this, start with the reciprocal function. So that's going to be 1 over x. And then now, if we multiply 1 over x times 2, that's going to cause a vertical stretch. So we're going to stretch it vertically by multiplying each y coordinate by 2. Awesome, you're still working. Okay, let's check that. Let me relaunch this poll. Okay, I'm gonna hold off on that for right now. All right. Let's try another one. What time is it? Let me check. See if we got any stragglers. We do. So let me do this for right now. Let me get these guys. Thank you. I forget who that is. I think it's the student. It's this one. So I think I got everybody that just let in, but it is a good idea. You definitely want to be showing your first and last name so that you can be sure that I'm not guessing the wrong name. There was one that was missing the last name, but I think I got the right student. Again, emphasis on the think. Let me go back to my poll. I'm going to relaunch this. And we're going to hold off on that for just now. Okay, so we might need a little bit more participation because again, I need at least 30%. If we do a poll, I need at least 30% participation before we can go forward. But this one is not a poll. Graph the following function, right? So we got y equals x squared minus 5, right? So the root function is x squared, and then we're subtracting 5 on the outside. So there's like each y value is brought down by 5. The x values stay the same. So all it is a U-shaped curve that should go down by 5. So in the upper right-hand corner, I'm going to click my U-shaped curve, and I'm just clicking on the origin. And we said we brought it down. So vertical, here it is, vertical shift we wanted it to come down by 5. So I'm going to put -5, and I'm going to hit save, right? See the graph? It's just a U-shaped curve that came down by 5. Let's check that result. Nice. All right, let's try another one. And again, if anything isn't clear, you just have to feel free to unmute yourself and get my attention. Okay. This one, we can do a poll. So let's go something like this. This one. Okay, and let's start the poll. Okay, so we're asked to graph, right? So there is a poll. I can't select an answer until I get at least 30% participation. So in Zoom, you want to choose either A, B, C, or D, and we're asked to graph. We have y equals the square root of x plus 3, right? Okay, we got one taken for D. That was pretty quick. Let me see. Can I see who that is? I know there's a way. I think I can do it when I click on in the poll, and I'll check that a little bit later. I'm tempted. I'm so tempted. I might do that for the next one. I'll do that on the next one. Because I might be able to do something for that. Maybe we can like do something interesting. Maybe. Okay, we got our 30. Okay. So let's see. Oh, we got some opposing views. All right, so now we're starting with square root of x, and we got square root of x plus 3. Remember, square root of x, the image is basically the top half of a sideways parabola. Notice that plus 3 is outside of our basic function, right? So if it's an outside manipulation, that means it's gonna affect our y values. Our x values are gonna stay as is, but it's only gonna affect the y. It should go up by 3. I can get down with D, right? So let's choose D and check the answer. God is good. All right, let's do another one. All right. I hadn't decided yet how I'm gonna do this, but I'm just testing it. It's like I'm open to some ideas. But it requires something. But I haven't. And I could do it. I'm totally just being lazy. I'm gonna relaunch, and we might do a little bit of a quick draw, something or another. Now, right now, it's not for anything, but I'm kind of open. Oh wait, somebody already chose A. Okay, before I could even like get it going, right? Somebody already chose A. Okay. Let me see. I went on to shut the poll down. I'm gonna leave that one be. I just want to see something. I wanted to see the results. View. I just want to view. I knew there was a way. I can see who it is. All right. So we got our candidate. I'm gonna go ahead and open the poll back because he did that quick, right? So I'm gonna launch it. He was like on the quick draw. He was waiting for it because I kept giving hints. Now again, like he's gonna stay with it. I'm gonna let it be. For right now, I'm just kind of being a little bit lazy. I want to do something, and I have some ideas, but for some reason I just don't want to move on it. All right. Let's see. But I don't think it's correct. I could go to the second person. Oh, he was quick draw, but being quick isn't always the best, right? Because now I'm looking at it, does not look correct. Okay, we getting varying results here, but this is all good. This is interesting because I could totally okay. So in the past, what I used to do, but this is before we were remote. Hey, it's 222. I used to give extra credit, right? This would be a definite opportunity for extra credit. I'm just being lazy, right? Like that's the thing. Now, I did have a student in one class. I don't know if it's this class or another, but he was trying to recover some points on his exam. He had done it a few times. He was like, his computer keeps messing up or this, that, and the other. He was like, he knows how to do it, but he just can't get the computer to give him credit for it. So, I think I would rather try to get some points on these exams. It's just a thought. We'll see. I'm just going to hold off for right now. Let's get back on task. So we're starting with the absolute value of x, right? And we want to go from basically the absolute value of x is a v where the vertex is at the origin. Now we have this -5 inside the absolute value, right? So since that's an inside manipulation, that should affect our x's. Our y value should stay the same. And it's the reverse of our intuition. Inside manipulations are generally horizontal changes, and they typically are the reverse of our intuition. So because we subtracted 5 on the inside, and it's the reverse of our intuition, that means if you follow the vertex, it should go to the right. We only got one person. Oh, let me close this poll. I got to see who that is because there's only one person. First, let me vote for B because my vote is B. I'm gonna check that one. Let me at least. I just want to see who that is. I just want to download the results. View. Where is it? There it is. Okay. I see you. I can see you. All right. So we got one that got it right? I was like, oh, I was trying to like give hints and, and you can like change your results, right? You don't have to stay locked into one until I like end it. Let's do another one, right? Now, if I were giving out extra credit, these are opportunities for extra credit, right? I think I'll be a little bit more open to giving out extra credit after the midterm, because after the exam too, and we got a little bit of rhythm, we'll know where we're at. Now, in the past, when I've done extra credit, let me go ahead and load the next question so you can be looking at it. When I've done extra credit in the past, so this one isn't multiple choice, so let me suppress it. Thank you. You can earn, in the past, I used to do where you can earn up to 10% extra credit, right? So that would be huge for you guys. Like, that means that if I were to start up my extra credit where you can earn potentially up to 10% of your overall grade, what that means is that honestly, you could like do all of your assignments like super late, but you would have to get a perfect score in these things. If you got 90% on everything late and you maximize your extra credit, you can still get like a full A, by the end of the semester. I mean, that's anybody all the way up until the very last moment, right? Obviously, you don't want to be in that boat of trying to get credit at the last minute, but if push come to shove, if you're maxing out your extra credit, I think I will do that. I think I'm really open to that. The only reason I'm really waiting until after the midterm is because I haven't really generated you guys a grade book yet. I will do that by the midterm. So that way, once I have the grade book, I can just put another column for extra credit and I can start logging this stuff, right?
I had one question. So I had came in late because I was in the
waiting room.
Right. However, my question is, how are we going to complete this midterm? Like,
it's just
do
like
we
exam.
like have one?
It's just like exam one. It's the exact
Oh,
same way we did exam one. It's going to be there. Because even once it's due, with all of our assignments, you can work on anything past due date. You still get unlimited attempts. So it's like, if you're trying to earn over 90, you just submit it.
right.
Time. But if you need more time, you can submit it past the due date and still earn up to a 90. Right?
Oh, okay. I understand now. Thank you.
It's unlimited attempts, and I think the system is set to take your highest score. So, you got to, it's a lot less stressful. Now, you're not 100% clear, but, it's sooner or later you're going to be able to do this stuff in like a testing environment. But for right now, just do the best that you can, right? It's okay. Let's look at this one. Let me see the time. We got a solid 20 minutes, a little less than 20 minutes. I graphed this function by starting with the function from the library function and then using transformations, right? So it looks like the base function is x squared, and I see two transformations. The recommendation was that when we're doing multiple transformations in one function, work our way from the inside to the out. So the innermost transformation here is at -2. So here, let's click on the graph. Okay, we can kind of still see it in the upper left-hand corner. The base function here is x squared, right? So that's going to be a parabola. And usually we start at the origin, right? Okay, so now it's just a U-shaped curve and we just did rigid transformation. So that -2 tells us what? We should go to the right by 2, horizontal shift to the right by 2. So I'm gonna shift this over to 2. And then we wanna go up by 1. All right, there. Okay, I'm gonna hit save. So it's just a parabola that we went right 2 and up 1. And I'm gonna check the answer. Okay, let's do another one. Similar deal, right? We're graphing. So I'm gonna click to enlarge. So now the basic function is gonna be x cubed. And that one is like an S shape. So in our options on this little panel on the right-hand side, it's the left-hand option on the third row. So if you go down to the third row, the left-hand option, that's our cube function. I'm just gonna click on the origin just to activate the graph. Now, I see two transformations. First we multiplied the outside of our basic function by a negative. So if we multiply the outside by a negative, that's like our y values are going from positive y to negative y. So it needs to flip over the x-axis. Okay. And then we subtracted 9 again on the outside of our basic function. So that means each y is basically, we're subtracting 9 from each y. The x values stay the same. So we need to do a vertical shift. We need to go down by 9. Are you doing that thing again? Okay. Let me think, how do I get that to work? I think if I reboot this. Okay. Come on. Oh no, see, that worked. It's just the keyboard. I might have to get out of it. Okay, there it is. Down by 9. All right, let's hit save. Ooh, okay. Well, the technology is totally temperamental. It's all good. We were able to get the keystroke in there. Like, this keyboard is kind of totally hanging on by like a thread though, because I initially got it, I was gaming, and 5-on-5 battle royale, multiplayer, people all over the world were all trying to get into this chat room and play together. And then it's basically a game of cooperation, right? So that's kind of, it's so interesting because that influenced the way I set up my course. Like, I'm trying to move away from competition and move towards collaboration. I feel like competition kind of like is stifling, right? And so that there are people that have gems, that have like talents and abilities, but because they're not encouraged, they just kind of like clam up, right? Versus a collaboration is like, well, anybody has anything to offer, we're trying to work together to just get this done so we can all share in the glory, right? That's, and like, so when I'm gaming, that's what it is. But in these games, I'm playing with strangers. And then some folks, the trouble are you either have trolls or you have noobs. Trolls are people that intentionally play bad, and noobs are people that just don't know what they're doing. So between them, I'm like, God damn, like ready to smash everything. So my keyboard is like, but that's not why it's messing up. The keyboard is just messing up. But when it does that, especially if I'm gaming and depending on it to communicate, so now it's like when I play, I try to play without having to talk. I just try to make my actions be clear, speak through my actions instead of words. Use transformations of x squared to graph this guy. Okay, let's click to enlarge. Let me just check Zoom, see if we got any stragglers. Let me end this poll for right now. That's fine. Let me close. So yeah, again, I am open, and let me stop sharing the screen for a moment. I am open to maybe considering some extra credit opportunities after the midterm. Okay, so yeah, I think this question got answered, but I'm gonna answer it anyway. In the chat, someone put, do we have a midterm for this class? And if so, how do we complete it? It's not really a midterm, it's really just exam 2. Let me get these gentlemen here real quick. Give me just a moment. Right, these are interesting names also. This one, and let me get this guy. Cool. I can let him in. Let's share our screen. Start the broadcast, and let's hop back here. All right, okay. So here, we're using transformations again. So the base function, we're starting with x squared, and I'll see 1, 2, 3, 4. I see a total of 4 transformations going on here. So I can see in the panel on the right-hand side that it's not the same as the previous. Basically, they want us to plot points, like 2 points. So what I'm going to do is I'm going to kind of track the vertex of, it's a U-shaped curve, so I'm going to track that vertex. So normally the vertex starts at the origin, right? Where it passes, the vertex is at the origin. I see we have a +5 on the inside. So what that tells me is that the vertex moves to the left by 5, and then we have a +3 on the outside, so it goes up by 3. So if I click on my parabola tool, if I go left 5 and up 3, I think we're here, right? Then for a second point, I'm going to go to the right by 1, right? So when x is -4, I'm just going to find the corresponding y. So when I plug in -4, -4 + 5 is 1. 1 squared is 1. 1 times -3 is -3. -3 plus -3 is 0. So when x is -4, the second point, we should have 0. Okay. So if you think in terms of transformations, we started with a U-shaped curve. We went left by 5. We did a vertical stretch by a factor of 3. We flipped vertically over the x-axis, and then we went up 3, and we finished here. But in application on this platform, again, what I did, those are the transformations, but really what I did, I tracked the vertex. So I know I went left 5, and then I went up 3, and I plotted the vertex first. Then I just say, okay, for this, I just like, okay, when x, I just went to the right by 1. So to the right by 1 put me at -4. When I plug in -4, the output that I got was 0. All right, so I'm gonna hit save. I'm gonna go with it. I'm gonna check. Awesome sauce. Okay. Again, if anything is not clear, you have to unmute yourself to get my attention. Otherwise, I'm just gonna kind of keep moving. Was that it? No. I wanted the next question. We are 8. We're about halfway. It's just loading really slowly. Okay. So, but I do like the poll because, that makes it so that this isn't so passive, right? It engages you guys on some level. Let me start the poll. I want to relaunch this. Launch. Okay. Now, I'm not giving out extra credit right now, but there may come a time when I give out extra credit, right? So with this one, and again, I can't move forward until we get at least 30%. All right. So I think that's like four people. We're halfway there. Okay. So begin with the absolute value function, then use transformations to graph. Now, looking at this G, I see 3 transformations. Oh, people dipping out. That's fine. Okay, we hit our 30. Okay, we got some varying results here. So another reason this is interesting to me. So I see that we have like 5 students in the chat right now, right? And so we got a live poll. So what this poll does, it kind of like acts like this thing called a hive mind, where the poll kind of serves as, if we took all 11 of you guys and treated you as one individual being, then right now 60% of the being is saying C, right? Let's kind of go through the spiel. I think by the time I'm done with the spiel, I'm gonna blindly take whatever the max is, right? So if we're starting with the V, and if we track our transformation, if we track the vertex, that +1 says to go left 1, we flip vertically, and then we go up 7. Okay, C is the max. Let's go with C. Let's see if C works. Okay, C is looking promising. Let's check. God is good, right? All right, let's go to the next question. That was good. All right, let me relaunch this poll. Relaunch. But that's good to know. Like I can get feedback. I can see who's doing what. That's awesome. I like it. Me like it. All right, right. So now this symbol, let's see if I can zoom in. This symbol is called the greatest integer function, right? It's called greatest integer. And so what it means, we didn't get a chance to talk about this when we were doing the lecture. But what it means is that the output is going to be the greatest integer less than or equal to whatever your x value is, right? So what that means is that, for instance, if the part inside that operator is an integer, then you just take the integer as it is. But if it's a number that's between 2 integers, then you take the integer to the left, right? So for instance, say we were taking the greatest integer less than or equal to 2, the answer would be 2. Greatest integer less than or equal to 7, the answer would be 7. Anybody got a favorite number between 1 and 1,000?
Five.
Okay, that was funny. Yeah, right. So say we took 5, right? So then say we did 2.005. The greatest integer less than or equal. So notice that 2.005 is between 2 and 3. So then the greatest integer less than or equal to 2.005 is actually 2. It collapses to 2. So whenever we get a decimal or a number between 2 integers, we take the integer to the left. If it lands on an integer, then we just take the integer as is. Let me do a couple more. Anybody else got another number between 100 and 1,000? Anybody got a favorite number between 100 and 1,000? What time is it? Let me see the time.
101.
101. Okay. So say we did negative, let's do negative 5.101, right? So if notice that negative 5.101 is between negative 6 and negative 5. So the greatest integer less than or equal to negative 5.101 is actually negative 6. All right. So whenever you get a number that's between two integers, you take the integer to the left. It takes a little bit of practice to kind of get that to set in. I see we got like 5 minutes. So let's take some time and give this one a go, right? So the greatest integer, when you look at the graph, this is called like a step function because the graph looks like the steps on a staircase, okay? If we consider the transformations, first we would consider that +1. That +1 would move it to the left 1, and then multiplying the outside by 3 should cause a vertical stretch by a factor of 3, right? So if we're causing a vertical stretch, it can't be B or D. It needs to be either A or C. I'm going to kind of bypass the poll for right now. So then if we went left 3, my vote would be C, right? Let me think. 1, 2, 3. All right. So for instance, when X is -3, let's plug in -3. -3 plus 1 is -2. Sorry. We didn't go left 3. We went left by 1. We did a vertical stretch by a factor of 3. So it is still either A or C, but we actually went to the left by 1. All right. So when X is -1, the corresponding Y is 0, and the one that X behaves correctly is indeed C. All right. So let's check that. Okay. So that was one. Again, we didn't get an opportunity to do it together, but it was definitely in my pre-recorded lecture. Write this function whose graph is this, but it's shifted 6 units, shifted to the right by 6 units. So notice we're doing a horizontal change. That means it needs to be inside our basic function. If we're going to the right, that means we need to subtract 6 on the inside. So then this guy is going to be X minus 6. Let's see, X minus 6, close parentheses, to the power 3. Okay. Right. So we subtracted 6 on the inside. Let's check that result. Let's do another one. I think we got time for at least one more. Okay. Yeah, I do want to use the poll. Let me relaunch. Launch. Okay. So this one asks us to write an equation that has a graph with the given characteristics. The shape, it has the shape of x squared, but it's upside down, shifted to the right 8 units and up by 4 units. All right. So which one of these results captures that? It's x squared, but then it says it's upside down. We're going to the right by 8 and up by 4. Okay, I'm seeing D a lot. Okay, let's see. Up 4, right 8. It looks good. Let's go with it. Let's go with it, just for the sake of time, because we're about out of time. Okay, that looks good. We got time for at least one more. Here's another one. This one is not multiple choice though. So write an equation for a function whose graph fits the description. Is x cubed. So let me start with x cubed. Come on. Parentheses. Okay. It says shifted 2 units left, so that means we need to do +2 on the inside. +2. Let me close my parentheses. Okay. Stretch vertically by a factor of 3. So we need to come back over here. Stretching vertically by 3 means we're multiplying the outside by 3. Okay. Reflected in the y-axis, so we're reflecting horizontally. So we need to multiply the inside by a negative. Let me try this guy. I'm just going to put the negative in front of this x like this. Okay. And it shifted 4 units up. Now, the only thing that might be thrown off is that inside negative. We're going to go with it for now. No. There we go. 4 units up, so we're going to say plus 4. Cross our fingers. Okay, it's that negative on the inside. We might need to, we might need to distribute the negative. So instead of it being negative x plus 2, it might need to be like negative x minus 2. Let me try writing it. Let me try just putting this like this. I'm going to do a parentheses here. And it has the same effect. Parentheses here, all right? So notice we did the plus 2 first. We're reflecting horizontally over the y. We could distribute that negative. I just want to go with this one. Oh, you know what? No, this is fine. Stop. X cubed. Oh, you know what? I forgot my cubed. Let me go back. Can I undo? That would be nice if I could just undo it. I forgot my cube. So before I do this parentheses thing, we might have to take an L. But I forgot my cubed. Because I think this is the proper way. Let's go to the power right here. Power of 3. Oh, that's not a 3. Come on. 3. Okay. Right? We did plus 2. If this doesn't work, the only other thing is change that plus 2 to minus 2. Cool, right? That was kind of interesting how that came about, though. We are essentially out of time, but we got it. Right? We were just missing what we had initially was fine. We were just missing the cube. All right. So I don't really think we took any notes here. Right. So that was fun. That has a lot of potential. That was a very interesting, unique experience. Are there any questions? Right. Let me see. So I might be open to some extra credit after the midterm. Again, it's not really a midterm, it's just exam 2. And it'll behave in a similar fashion as exam 1. I acknowledge that, you guys are college students. I'm not the only class that you have. Trust me, these things, you have at least half the workload than students of the past, right? It was twice as much information. But what we ended up doing was broke it up into 2 courses. So College Algebra 1 and College Algebra 2. So we're just doing 1 section a week. And honestly, there was a time we were doing 4 sections, like 2 sections a day, right? So we were doing like almost 4 times the amount of work. There was something else. But yeah, so for you all, just make sure that you're making your way through the assignments. If you're kind of like waiting on funds, it's going to be okay. You're just going to, if you're still waiting on funds and like you got locked out of your Pearson, you're just waiting for the funds to appear, then you want to keep practicing on some level. So that way, once you do gain access again, then you can kind of just like keep working. The late penalties are going to stand, and it's not heavy. You just want to try to, the main thing are the exams, right? The exams have the heaviest weight. All the exams total for the entire semester is like 80% of your grade. Those are like 4 exams 1, 2, and 3 in the final. Homework and quizzes, do the best you can with them, okay? If there aren't any burning questions, we're going to end the session here. And from one beautiful mind to another, enjoy the rest of your day, guys. Take care. Peace.